how's your name pronounced?
Get or Diddy. Everyone calls me Diddy.
Diddy. Whenever you're ready.
Yeah.
You can go now?
I need the slides.
Okay.
If it would work.
So you have to do it. It'll work. Did you
What?
get the turns off?
I can do it. You can start talking.
Okay, so after so many problems, we finally got here. This is the talk about programming the cloud by Didi. And in the other rooms, there are two other talks. Rootkits are awesome in Monty Hall and design and build cyclotron in the birthday tent. So Didi, floor is yours.
Hi, sorry for the cable malarkey. Programming the cloud is what we're going to talk about, or the subtitle is Objects in the Cloud. I'm Hoffman Gert Dietke. No one can pronounce that, so everyone calls me Diddy, or Ribalba is my sort of internet name. I just graduated from Bournemouth, and my final year thesis was about cloud computing and about what I'm going to talk now. So just so that you can sort of know what you can trust me. My website and my hack tags and my email and a nice picture. So what is this talk going to be about? It's going to be about cloud computing and why it sucks. Really, I mean, everyone I talk to says it doesn't work. Overview how it's done nowadays and what the new techniques are. A little solution proposal, what my idea is how this can be changed and how it can suck less. An object is a solution or a proposal, and why, how, and whatever. And a little outlook into the future, what I think, how it's going to move and what's going to happen. So what is this talk not going to be? So please leave. It's not going to be what the cloud is. I'm just assuming you all know what the cloud is. It's not going to be how to program or anything like that. It's not going to be Amazon is better than Google and Google kicks ass Microsoft. I don't care. I'm biased. Really, take that into account, and I'm not very politically correct, so please don't be offended. Okay, so objects in the cloud. What people imagined, like every time I said, okay, I'm doing objects in the cloud, people said aeroplanes, angels, everything. But no, it's all wrong. Objects in the cloud are objects as seen in C++, Java, this type of object. And how can these objects be distributed into the cloud? Whoops, yeah, okay. So basically, if you see the UML, yeah, okay. What's the problem? Hardware has been moved into the cloud. Amazon has their hardware store, you can have virtual machines. OSs are pretty much independent in the cloud because you don't really care about what OS you're running. But software, not in my eyes. And now lots of people will say, oh my God, how can you say such a thing? Software is the next big thing in the cloud. Everything's in the cloud, but it's not. People write their software, and then they write some output filter, and they're locked into that service. So if you go to Google and you write your cloud service there, you're locked into what Google uses. If you go to Amazon, you have to use their storage technology. Otherwise, you have to use some SOAP, some Corba, something funky to talk to something else. So it's not, you're locked into your service provider. So if you use Google, you have to use Google. There's no way of saying, okay, I want my storage to be, I don't know, Dropbox or whatever. Because there's no real compatibility there. It's just like, you're with us, you use our technology, everything will be fine, it will scale, you're in happy land. But as soon as you say, okay, I don't want my data to be on Google because I don't really trust them, I don't want them to cache everything in America or whatever, I want my data to be in Amazon Europe, then it all becomes difficult. So I say, this is not really working. And yeah, software, then you try to emulate, there's loads of middleware research where Max has one machine, but that's really not working. So currently you've got all these cloud providers and they don't talk to each other. So what in the end you've got is you've got loads of different clouds. So let's say these are the services you use. You use a text pad, you use a folder, file saver, email. You've got loads of private different clouds that are in the cloud, accessible through the internet, scale, whatever. But they are not connected. And that's a big problem because that's where actually the power comes into place. The big power is that you can have all these services and they can talk to each other because they have really quick bandwidths to each other. Google and Amazon, they look at each other really, really quick because they're on a backbone. You're really lacking in the end. So what's the solution to this? Distribute objects. Everyone knows object orientation programming nowadays. Why are we locked if you have an int? Why does the int have to be on your computer? Why can't the int just live on intserver.org? Why do you care? And why do you... So through this we have one big cloud, and this will be a little bit bigger. So this is a language I developed to sort of attack this problem. And so let's say you have a file that's called event. And so you just say file equals new file, event, the name, at, and then openbox.org. And this will, if OpenBox implements a server, blah, 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 this will trigger a new file event being created on the OpenBox server. And you can use it as an object. As you can see, I do file.addLine event.value. So, but this is totally transparent. You have no idea where OpenBox is saving this. And even your cal, that you have an event then, an event object, event equals cal event, you've got no idea where this lives. But these two servers then will negotiate and say, okay, give me the data I need to save this. So if you're working on your PDA or something and it's a really shitty connection to the internet, you don't care about it. You just say, okay, these are the two things I want in the web. This is the data. You say your event and your date. This is what's uploaded. And then it's all done in the cloud between different service providers. So in a way, it's bringing the cloud to one big cloud and not lots of little clouds with all the service providers locking you in. Does that make sense? In a way. Yeah? I tend to be very abstract about this. So object is the objects in the cloud language, with object CC being the compiler. And so I thought, so why do we need all this? And then I tried to extend Java, Python to do all this, but none of them really fit, because none of them really have the memory management modules or something to do this. And it would have been a massive thing to implement it in Java. So I wrote my own language, and it's very Java-y, Python-y, sort of everyone with C, Java, Python will understand it right away out of the box. So, and it's the usual stuff, and the main thing is the bytecode. And this bytecode is interpreted in a virtual machine running on a server, and it's a closed virtual machine, so even if you have 1,000 objects living on one server, no object can see what another object is doing because it's a totally different memory segment. It's not a real virtual machine with an operating system, but it's a zone in Solaris, if people sort of understand the concept of that. And you have a server, and then ORun is a big runner program that will run this bytecode. The bytecode is Indian independent and it's totally distributable. So let's say you've written this really good implementation of an int, but you don't really want to say, okay, this is the source code. You can just give him the bytecode. He can put the bytecode in his object server, and the object server will happily create ints of this bytecode. So then the next question was, how can these objects I create all over the internet talk to each other? And one big thing is SOAP. Massively hyped with Web 2.0 and everything, so SOAPs is a big future. And then I did some tests of parsing XML, and it's absolutely horrible. I mean, the overhead you have to parse just to call a function in SOAP takes minutes. It's ridiculous. So I extended HTTP and made a very small, simple protocol, because at the end of the day, the only thing you have to transmit is call this on this is a reference to this. And this is just a little comparison. If you look at the SOAP and the object protocol of the execution time and the system calls and the file size of the call, well, even if you don't believe it, your handheld device going over some 3G network, data size is still vital. I mean, it's still important. And so SOAP was just far too slow for anything to go in real time or even be usable in my eyes. So the source code, can everyone read this? No. So basically, you can have classes, user-defined classes, so that you have a class, you compile it into bytecode, and then you can ship it off to your cloud server. This cloud server can be locally on your computer. You have no problem in development. Like for a test thing, I wrote everything on my computer locally, and then I just said, I changed, okay, the object location now is on a server I had in America. And I just had an object server running there with the same class files, and it worked. Because you just say, okay, all my mail objects at that time are on my server in America, and then all mail objects will go off to America. And then they live on the American cloud server, and you can access them locally from your home machine. So it's very easy for you to develop an application locally on your machine and then move it into the cloud, because you're running a cloud server effectively on your machine for standard in and standard out in the first place, because you want them to be local. Whereas a friend of mine, he had standard in and standard out on a log server, and through that he was logging everything the program was putting out. And then he sort of said, okay, now I've got the log files, and for this, he moved everything into the cloud. He had his Amazon S3 storage, and that was his log files, and he just saved it there, and that was it, and he copied them. So you have functions, the usual stuff is you can see the Python def main, and you have args, and you have input outputs, strings, int, whatever. And it runs. So everything's written in Python for now. That will change soon, I hope. So basically, object is the compiler, and then I compile it, and then I run the example with 5, and it multiplies all the numbers till 5. So, what are the main features? What are we gaining out of all this? So we have distributed object instantiation in a very easy syntax. And that's a main thing, because every time I saw, we can have distributed objects with some middle layer, it's very hard to set up. No one understands it. There's one nerd in the company that really knows what it's doing, and no one else understands what's happening. It's very easy because you can specify in the source code, these objects live on that server. You can say globally for this program, these objects live on that server. You can say for this class, these objects live on that server. So it's very easy to see what's happening and to distribute the objects instantiation. You have base objects. Everything extends from one object, as you know from Java or whatever. So that's quite nice because everyone has a default output filter, so you can debugging is easier through this. User classes, that was a main thing. That was when that was reached, that was a big step. You can now define your own classes and ship them all over the world and use them out of different programs, and it all seems to work. Different stacks. Conditionals, memory management is a big problem because you've got no idea how long that object is going to live. Because you're pushing pointers, if you say add this, if you've got two objects living on two servers and you say add that value to that value, you lose a reference, and then adding those is very complicated at the end of the day because you don't know what is pointing to an object. Is the network connection down? It's very hard. So memory management is a big problem, and there are lots of papers being published on this, and I've done some research, and it's really, really hard. I mean, distributed memory management is always hard, I suppose. You have while breaks for user functions, returns. Everything runs on an object server. That's important too. Everything you write runs automatically in an object server. So everyone who has this object server running on a machine can implement your class. So you can easily distribute, or you can say, let's say you've written a really, really good encrypt function, and you say, okay, I want this for the world. I want people to be able to encrypt their objects with my encrypt function. You just say, okay, my object server is public viewable, and you make a little website saying, hello, this is my server, and this is my encrypt function, and then everyone can access and copy their objects onto your server. You encrypt them and send them back, or send a reference back. So you hold the data. This is quite important too. For example, if you've got a big company, and you, let's say you have mail objects, you don't really want those mail objects to be hosted by Google, or I wouldn't want them, because if they will peek into them, you don't know. And so what you can do, you can have the mail objects locally on your computer, but have all the functionality from Google. So let's say Google will sort your or search your mail, but only the headers, so you can only transfer the headers to the Google server and say, look into the header file, or look into the titles of the mail, but you're not publishing your body of the mail, what's important, or whatever you see important. So and user classes 2 times. So a problem. So I was just explaining that you can basically have objects on different machines and you use them and it's quite seamless. What happens if that guy who provides this object server decides, oh wait, this sort function is broken, and changes it, but you rely on that error? I mean, there was a big thing in Java and people were actually relying on this to error and actually used that error. So you've got an object versioning problem, because if someone updates the object and it's not your object, or the class, the base class, let's say, you instantiate the object, your program will fail because you don't know this has happened. So there has to be some versioning system. That's not that simple, because obviously you want bug fixes that don't affect the output or the black box. You want those to happen, but you want white box bug fixes. You want to see those and you don't want to use those. So should the service provider have 20 class files or objects lying around, or how should that happen? There's no real solution yet to this. Inheritance is quite difficult, because that sort of builds on garbage collection. If you inherit from an object, are you going to copy the struct, or how are you going to do that? Public, private, for now everything's pretty much private, except if you specifically say, do it. But then of course you want specific data to be public and private. For example, if you've got a person object internally to your company, you want all the data to be public. But to the outside world, maybe you only want the name and, I don't know, the email to be visible, so you can have a website or something. So it's not that easy to say, is this going to be public, private, or what is this going to be? Garbage collection, as I said, and security is a big issue, really, in the whole cloud computing thing. Sometimes I'm amazed what people just do. They upload all their financial records onto the Amazon cloud, and then they say, yeah, that's in America and everywhere, and I don't really care who can see it, and it's the main core of the business, and they just upload it into the cloud. And I'm like, okay, would you really want to do that if you're like the boss of a company? And I don't think people really understand the real security issue that this whole cloud thing is bringing. But, yeah. So, the future, or what I think the future will be, obviously no one can see into the future. I think cloud providers will have to sort of agree on some sort of protocol to talk to each other, because it's just unacceptable to be locked into one service provider and then relying on him to do everything for you. And if you want to use something else, going through SOAP, going through all these protocols and reverse engineering it back, somehow it has to be more scalable, that you can use different storage providers, that you can use different CPU providers. Actually, why do we have to care about this? You know, why does it matter? Why can't I just move my data instantaneously? Why do I have to migrate all the data if I move from Microsoft to Google? That should just happen like that. More data is going to go into cloud. I mean, everyone I talk to is saying, oh yes, we're going to put everything in the cloud and everything's going to be glorious. I don't believe in that. And a really big trend that you can already see now is you're not going to have the big box under your machine anymore, or your mum or your parents, or I don't know, you probably, because you're going to develop. But the normal user is not going to have a big machine running away, chundering on Office or whatever. This is written in Google Docs, totally online. You can write it on my PDA, on anything. So you're just going to have everything being processed in the cloud and everything going to move into the cloud, and your handheld device or your computer is just going to be the output device. I mean, Amazon has got this cloud rendering service where you just get the images as a video, basically, and then they render everything, so you don't even need a graphics card anymore. For objects specifically, more failover. It's still quite flaky if the network goes down, and there's a problem if something updates and then you don't really propagate the update, so caching is not done, because if the network's down, that's your object gone. Very simple. You can have multiple servers that hold that object and they synchronize to each other. But what happens if you update one object, and how does it propagate if they can't talk to each other? So there's a lot of issues here. And so failover. Currently I'm writing a model notation, because more and more stuff is going to be software as a service and just plugged together. I mean, the US government said 80% of their software has to be off the shelf, and that is only manageable by plugging software as a services together, but there's no UML notation or something for this. So, and the idea is to integrate this into Object, that you have a notation where you just say this server talks to this server and it will do it for you. Private clouds, I think this is not really being realized yet. You can have a private cloud quite easily. You can just have 20 machines and have a few virtual machines you sell even or something. Lots of people think, yeah, we're going to buy stuff, but you can easily have a private cloud for your private data and then back the data up into the cloud. Let's say you buy storage from Amazon, you zip everything, you can compress everything, you put it onto Amazon, and that's your backup. But you've got your own little private cloud for access time, and you've got control about the data. So I think that's going to be a big hype. Payment would be really cool, and I haven't really got any plans for this. But let's say you've got this really, really good encryption algorithm or this really, really good class that you publish to the world. And then you say, okay, everyone who uses or instantiates an object on my server pays me half a cent. Or something like this, so that you have a dynamic payment method in there. But then I don't know anything about money. More authentication, like a secure authentication. It supports SSL, but that you have a secure authentication, that you have passwords and stuff like that. Different output filters, like for now the output filter is only a shell script and a JavaScript. But this is already quite good, because if all your objects live on different servers in the cloud, the only thing you need is a little JavaScript running in your browser, and that will go off, and basically it instantiates a standard out object in your local browser, and then it will go off and get all the data in the cloud. Everything is done in the cloud, and you only get the output through your little JavaScript app, what is effectively called standard out, and you only get the result. Through this, you can have a very, very low power device or a very low spec device, and everything is offloaded in the cloud, and the only thing you need is a very, very small piece of software that basically just says, okay, give me the data. That's all it does, or uploads the data you enter into the cloud. And encryption is a big thing, and of course everyone in the cloud wants to encrypt everything and wants the same speed, but I haven't looked into that too far yet. Okay, and that's broken. I need your help. Basically, it's only me doing this. If you're interested, contact me, send me an email. If this sort of seems a little bit freaky, just talk to me. I mean, we can discuss something, and I can't do this on my own, and I even got a PhD on this, and 3 years is not even going to be enough for the protocol. So, open source, help. And now the idea is that we have sort of an interactive session thing that you ask me and I ramble about stuff. Questions? Well, was it too much, or I don't know? Yes?
Does it run right now?
Pardon me? Yes. If it's running right now, not on my laptop because I just formatted it. But if you go on object.wait. No. Shall I try to get... we can look at the screenshots if you want, but I don't have a running demo on my laptop, sorry. I can try to get one running if that's a general thing people want to see. Is it? Yeah? I excuse my background picture. So I'll just talk. Wait. So this is the object location file. Can everyone see that? No. How do I increase font size in Xterm? Control? Yep. So, basically, this is the object location file. This is globally for the object server where to create the object. So now I'm saying int should be created at localhost and string should be created at localhost. Let's say you deploy this onto, I don't know, some server. The only thing you have to change to enable that it's not anymore on localhost is you say int at whatever server name and string at whatever server name. And then all the int and all the string objects in that server instance will run on those servers you specified. So let's see if the server will run. Seems to run. So now you have the user classes. So now you can see I've got the multi RTI, that's my bytecode. I don't know for what it stands, but basically that's my bytecode. That is then read by the object server. So if I say orun, which is the run, and actually we can look at the orun source code just to show you how easy it is. Basically, I just create an output object, and that's it. So this is all you need on a device to access any object that lives in the cloud. So that's with a lot of comments and debug output. That's 120 lines of code. That's all you need to run on a local instance. But now we'll call it, and we'll call multi, and we'll call 5. So now we'll have a look at the multi source code. So did everyone see that? So I call orun, multi is a class name, and I give the parameter 5. So then if we look at the source code of multi, examples. So basically main is the method that is called when you enter. This can be changed if you want to change it for your company. And then everything that's transferred over the net is a string, even an int. I don't care about typing, I duck type. I don't care. What I get in, I decide what that's going to be. If that's a 1, like the 5, I get in. I say, okay, it's an int that you can see here. Basically, I say, okay, argint is my value I get in, and I say this is a new int of type 5, or in this case. Then I create a return buffer, new string, and then I call me is this or self or what, all this, like call the own class. And then I call the function multiply, which I've written up here, and so you've got def, everyone who knows Python understands that, def multiply, and then of course, because it's a method in the class, you have to say this is an int again. You have to call, because you don't know what's coming in, because this could be called from somewhere else. Who's saying this is called from main? This could be called from anywhere in the world, passed in something, because it's a method. And then I multiply it, like int has the method mul to multiply itself, so it multiplies 1 times 1, 2 times 2, and so on, and returns the return value, which I then add to the big string here. Like I add to the string the return value, and I add a space, and then I return the return buffer. And let's say ints should be, I have no server instance running somewhere else, but it would be very easy to say ints should run somewhere else. I could easily say let's say, actually, there's a demo here. Me at home is my local machine name. So I say, instead of ints at localhost, I say me at home, which is of course localhost, but this could be something else. So the int object that actually is used to multiply is distributed at me at home. Does that make sense? You have to say if this doesn't make sense because it's quite... Yes, please. Exactly. So basically, if I, in the protocol speak, if I write arg equals new int, the args, what I do, I say connect to the server me at home through whatever, then say, okay, create a new object with a type int with the parameter argv, create this object, and then the only thing that is stored in the args int variable is a pointer. That's the host name and then a hash. And through this pointer, this object is uniquely identified throughout the whole internet. So I can easily pass this pointer around, and with some security credentials added, I can easily connect to this object. And and so then it says, okay, do this, and it waits. There's no local caching or something, because you don't know that the int implementation on me at home could be totally different to my local int implementation. I might have an int that only has add, minus, whatever. But let's say I have int server, and they have loads of brilliant functions and whatever. I don't know what they have when I write the code, when the parser doesn't know what. He was first, sorry. But, yes.
So, if you ask an int object to be multiplied by some other int object which lives on another server, how can it do that in the sense that it knows how to multiply itself with something, but that something else is an int object on another server, and they kind of need to cooperate to get multiplied value.
What they do is cooperate. So basically, if you look at the argsv, I say new int was argsv. The argsv object, or what I put in there, is just hostname, the hash, and some security credentials. And then at me at home, the server will go off to the server that value is pointed to, say, I want the value of that object because I'm going to add myself, or I need the value. It says, get the value of that object, adds itself to it, creates a new instance, because you want everything to be a new instance. You don't want objects to be really changed, because then you get in horrible situations. So ints, you create a new object with ints, strings too, but user classes obviously stay the same. And then basically, it points it, gets the value, multiplies, adds, whatever, creates a new object with the new value, and returns back and says, okay, this is now my current value. Does that make sense?
Yeah, but so you have a distinction between the integer data that it fetches as a value and an integer object in which it lives. Because
yes. The int data is just a string at the end of the day. It's a string nicely wrapped. It's just 1, 2, or whatever, and that's seen as a string and then parsed. This is a little bit slower because you have to say, okay, this is really an int, so this is not a string, give me 5 or whatever. But through this you gain total security. Maybe in some language you have a weird number that is some symbol, or in hex, for example, you could have int objects that have hex stuff in it, or E or something. As long as the implementation of the object you're talking to understands this, you're fine. Even if your local int object doesn't understand it, you know on intserver.org, they know I can have an E or something in my number, and because it's a string, they say, okay, we'll cast it, and they understand it, and they will process it for you. You don't have to care about that. Yes?
I think my question may have already been somewhat answered. I was wondering, you've got a single file that says ints are stored at int server and strings are stored at string server.
That's a global file, but you can have it in the code, or you can have it per class.
Okay, yeah, that's what I was wondering. Could you have one int stored at one server, one int at another server?
That's possible. Normally, what I experienced while developing this, that in the end of the day, you want all ints to be on one server. You want all strings to be on the other server. You don't really want to specify every int or every...
Integers and strings are probably overly trivial examples. But suppose I've got an agenda where I keep all my appointments on a server, and a business partner has an agenda on a different server.
Yes.
Then I may want to write a program that compares those agendas, so we can make an appointment. And then you've got similar objects on different servers.
Then you would just say, create a new agenda object on that server, or connect to the agenda object on that server, connect to the agenda object on that server, and then one of those would have to have a compare method, because obviously, or you would have to get the data and compare it yourself, because no one would know how to compare these two objects. But let's say you write the agenda object yourself, and then you say, okay, give me the first record from this, give me the first record from this, compare it, and then you can easily communicate with a while loop.
Yeah.
You would have @, obviously you would have agenda1 at agendaserver1.com, agenda 2 equals agenda server 2.
Yeah. What I'm also worried about is won't you have two volatile interfaces for your objects? Because if one int server has a certain implementation of an int, another int server has a different implementation, providing different methods.
Well, that's hidden, isn't it? Because let's say your agenda is the front end, and you have different ints. If you get the int, the int would point to the int server that you have. So at the end of the day, one of them has a compare method. Does that make sense?
For example, but suppose one agenda server does have a compare method and the other doesn't.
But you would have to know that.
Then you've got two different versions of the same
You'd have to know
class.
that as a programmer.
What?
You'd have to check the class API as a programmer to see how the class is made up.
Yeah, but it's going to be API hell because you'll have lots of very different implementations and different interface probably.
Hopefully not, but hopefully there'll be one major. But the same as with Java in the end of the day.
It's exactly what I was thinking about.
With Java, you have
like
200 versions of anything, but hopefully, of course, everyone would use one thing, but that's never going to happen, I assume. Yes? Someone else? No?
Anyone else?
Excellent. Cheers. Thank you.
Okay, thank you, Didi.